Hello, 11.3, this is the surface area of a prism, page 183, 184, 185, and it says question 1, here is a net of a cuboid, in other words a shoebox, work out the surface area of the cuboid. Now essentially we've got something like this, so I've got that, again freehand drawing, not brilliant. Let me use my artistic talents to show you that it's 3D. And there you go. So if you imagine this broken open, we sort of split it across all the edges and bust it open, I'll get something like this. It's not asking me to work out the volume. I could easily take these numbers, put it on my diagram and get the 3 lengths I need to work out the volume. It's not asking me to do that, so I won't do it. I'm just showing you that in fact a shoebox or a cuboid, if it's got a top and a bottom and all the sides are intact, I can break it open and get 6 surfaces. So therefore the surface area must involve working out the area of all these 6 little rectangles that have been exposed. So let's just do this one first. It goes 15 times 4. That's him done. Look, that's another 15 by 4 because it matches this one. If I shade that one in black with that one in black, then you know they match when they fit together. So I've got another 15 by 4. I'll work it out in a minute. I've got the edges here and I'll shade him in blue, so I've got this one that's 4 by 7, look, 4 by 7, so I'm going to shade this one out as well, so that's 4 by 7. I've got one downstairs as well, 4 by 7, and then I'm going to do the bottom of the box, and that exactly matches the top of the box. I'm going to shade them all in a common colour, which is going to be red. Alright, so that's that one, and it's 7 across by 15 long, so 7 by 15, look, there's another 7 by 15 there, so I've got a 15 by 7 or 7 by 15, makes no difference, either way I've got 2 of them, and then I'll get the total surface area. By adding them all up. Okay, right, 15, let's go for a different colour that I've not used. Pick a different flavour. Let's go for something like that. See if it allows me. Okay, 15 times 4 is 230 is 60. So that's 60. That's 60 as well. 28, 4 sevens, 28, 4 sevens. 7 15s is 70 plus 35, 105. That's 105 as well. Pick up my calculator. So I've got 60 plus 60 plus 28 plus 28 plus 105 plus another 105. Altogether now I've got 386 centimeters squared, because this is an area. All of these are centimeters squared because they're individual areas of rectangles, and I've got 3 different pairs of rectangular faces put together to make a lovely cuboid as seen just there, and final answer is 386 centimeters square of card if I wanted to make that particular box. This one's a little bit more difficult, is working towards grade C. Right, triangular prism. So if I draw, it's based on a right angle triangle as well. So here's a right angle triangle, supposed to be, and it sort of goes back like that. So if you imagine that, and then this sort of comes across like that, all dotted, and then I can join these ends here. So effectively I've got that drawn freehand terribly, but that is a representation of that. If I break this open, I've got 1, 2, 3, 4, 5 different surfaces. Now no 2 are the same apart from the triangular faces there and there, so I've got to work them out individually. I've got this one first, which is 3 by 20, so I'm going to put it down here, work over here. 3 times 20 gives me 60 meters squared. It's an area. This one's going to be 4 times 20. 4 times 20 is 80 meters squared. This one, 5 times 20. 5 times 20 is 100, and that's in meters squared. Now here and here, the base is 4, the height is 3. Now don't be fooled by the 5. I needed the 5 in order to show that it matches this 5 here when these 2 edges meet to make the triangular prism in 3D. So I don't need to use it in the calculation, because you know for triangles it goes 3 by 4 meters, half base times the height. So here I go, half times base times height. Well, that's going to be half of 12 is 6 meters squared, and the other one is exactly the same, half times base times height, that's 6 meters squared. Let's get a total volume, and that's going to be, I don't know, plenty, isn't it? 240, 252. I'll make that 252 meters squared, and being a coward I'm going to use my calculator. So 60 plus 80 plus 100 plus the 2 6's is 12. Yep, I've got it right, I'm happy. And that is the answer to part A in meters squared. Let's just change flavour to go centimetres squared. Now look, let's calm down, this is quite difficult. I think I showed you in a previous video that, let's just do it anyway. Volume, no sorry, surface area. Oh, it is easy. Look, if you remember that a metre square is essentially 1 by 1, 1 metre by 1 metre, that's the same as 100 centimetres by 100 centimetres, because 100 centimetres is 1 metre, isn't it? And 100 by 100, well, that makes 1 metre square, but 100 by 100 is 10,000 centimetres squared. So they want this in centimetres square. Okay then, I'm going to take my 252 metres squares and multiply it by 10,000, and I will get a very big number. I'm going to get a 252 followed by 1 2 3 4 zeros. 1 2 3 4 zeros. So let's put the commas in now. 2,520,000 centimetre squares of area. Sorry, I got confused there with the volume. No need for that. It just, I saw a 3D shape and just played tricks on my mind. Alright, so that will do as starter videos, and maybe I should do the next little bit. Yeah, no, save for the next video. That's alright. Okay, so you study those two questions, and then we'll move on. See you soon.